Okay, the first question of this June 62, June 3rd, 19 and variant 62. Guys, it says there are two fair dice. Okay, even S is the sum of the numbers is even T the sum of the numbers is either less than 6 or a multiple of 4 or both. Okay, so S means the sum is less than 6 and T is um, oh, come on. It says the sum is even. Okay. The sum is even and the T is sum is less than 6 or a multiple of 4 or both. Okay, to answer this, we need to have the table diagram. Let's draw that quickly. Okay. The sums are going to be 2, 3, 4, 5, 6, 7, 8, 11, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 4, 5, 6, 7, 9, 10, 9, 8, 7, 6, 5, 6, 7, and 8, and then these are the sums. Okay, now let me highlight the ones which belong to the set S. Okay, so the sum is even, so half of them they are even. Okay, so I can simply say the probability of S, that is going to be half. Okay, and then the next one is the sum is um, less than 6, multiple of 4, or both. So let's see which are these. Less than 6. So this is this. So these are the sums which are less than 6. And then there are multiples of 4. So this is going to be this, okay, and this. Okay, so yes, this is or both. Okay, so they are less than 6 or both. So let's count how many of these are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the probability of T is going to be 16 over 36. That is going to be 4 over 9. Okay. Now let's see, like if is asking that whether these two events are independent or not. If they are independent, then probability of S and T should be same as probability of S times the probability of T. Now let's find probability of S and T. So it should be the ones which are crossed and out of them which are even. Let's see how many of them have both the properties here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10. So 10 of these are here which are both S and T. 10 over 36. That is going to be 5 by 80. You can clearly see that probability of S and T is not equal to probability of S times probability of T. Therefore, S and T are not independent. That is how you will be responding to this. Do we have any question, Bacho? Question number 2. The volume of ink in a certain type of ink cartridge has a normal distribution with mean 30 and standard deviation of 1.5. Acha, bacho, the thing is that a very major segment of your statistics syllabus that contains this normal distribution. And the good thing about it is that you don't have to think about it if it is really a normal distribution or not, because in a question of normal distribution, you will always be given that fla has a normal distribution as it says here. Okay, and remember to note down its parameters here. So this is basically you have to like start saying that okay, let x is, this is how you have to write it, okay, is normally distributed with the mean 30 and the standard deviation 1.5. So you will put a square on it because this has to be the variance over here. People in an office use a total of 8 cartridges of this ink per month. Find the expected number of cartridges per month that contain less than 28.9 ml of this ink. Okay, so we'll basically be finding the probability of x to be less than 28.9, and then we'll multiply that probability with this 8. This will give us a probability that out of 8, how many of them can have ink less than this, given 28.9 ml. Okay, so you have to find this. So your first step is always to standardize. Okay, so this is z is less than 28.9 minus the mean over the standard deviation, so which is given as 1.5. Okay, so let's use the calculator. So this is going to be what is this, Vacho, when you use your calculator? This is phi of minus 11 over 50. Yes?
हमने 8.9 को -0.5 क्यों नहीं किया? क्योंकि in the question it says कि
because we are not approximating this to be a normal distribution, okay. Acha, so since this is already a normal distribution, you do that when you go from binomial to the normal, okay. So that is why this is not required here. So this is going to be 11 over 15 as a decimal is 0.733. And please write this correct to 3 decimal places to see this from the table efficiently, okay? So let's see what is this 0.733. Okay, 0.733, we have to find its, okay, 0.7123. This is 0.73. And then there is another 3. That is 0.7682. 0.7682. Okay, so we get 0.318. This is not our final answer, okay? So the expected number of cartridges, you have to write all of this, okay? That is 8 times this, times 8. That is 1.85. It means it is going to be 2 cartridges. Okay? That is your answer to the second question. So I move to...
I have a question.
Yes, beta, yes.
Sir, if we have to subtract 1 minus 5 of something from another side, do we need to change the signs?
Which signs? Where?
Sir, like we do in subtraction, like we do in BOD mass, do we need to change the signs too?
There is no such board mass going on, beta. This was phi of minus 11 over 15. Okay. So we have a rule here that phi of minus a is 1 minus phi of a. So we have only done that thing here. There is only minus thing here. Third question, the probability that Janice will buy an item online in any week is 0.35. Janice does not buy more than one item online in any week. Okay, so that means this information is really important, that one item means 1 week. 1 week would mean one item. Okay, find the probability that in a 10-week period, Janice buys at most 7 items online. Acha, bachcho, whenever you have a question on probability, you see, you have to really think that from which distribution do we have, this question. Like you have discrete, random variables, and for that you normally write a simple probability distribution. Remember that table, okay? Then you have the binomial distribution. Okay, in a binomial distribution we deal with the discrete data. Okay, the data is discrete and we have the number of trials and we have the probability of success. Like you have here this 10-week period, that is your n, and this 0.35 is your p. Then you have geometric distribution. Uh, and this is its parameter is simply p, and the question says, okay, find the probability, like if it says probability x equal to, let's say, 5m, so that means it is a time when the success is going to happen the first time, so that is going to be q raised to power 4 times p. That is how you find this. Okay, and then you have the normal distribution. Okay, and the good thing about the normal distribution that you people are given that this is a normal distribution. This deals with the continuous data. Okay, and its parameters are mu and the variance. So if you look at all these four carefully, you must be able to finalize, determine that yes, this question is from a binomial distribution, because she is going to buy these items, one item, okay, per week. And this is the probability that she buys anything online. And out of these 10-week period, where you find the probability for this happening at most seven, like times. So this would be, you would say, okay, let x is binomially distributed with n as 10 and the success probability is 0.35. You can mention here that your n is 10, your p is 0.35, and your q is going to be 0.65. Okay. And then it says probability, it says at most 7. That means less than or equal to 7. Where to find this? So, but you're at this level, you have to decide if either you would be, oh, sorry, I have written this wrong. This is at least 7. Oh, no one told me. This is at least 7. At most 7 means less than or equal to 7. At most 7. Okay. So, would you be finding the probabilities from 0 to 7, or would you like to do it like this? 1 minus probability x is greater than 7. I think you will have to work less if you go for this option. It says 1 minus probability x equal to 8 plus probability x equal to 9, and then probability x equal to 10. Okay, and this would be 1 minus, we will have 10c8 0.35 raised to power 8 and 0.65 raised to power 2. Some people really mix it up with the pure mathematics binomial expansion. So there you have NCR, A raised to power n minus R and B raised to power R. Okay, so it is different here. Here this R and this R match, but in this binomial distribution, you have NCR, P raised to power R and Q raised to power N minus R. So here these two actually match, okay? Okay, anyhow, so this is going to be plus 10C9. This is 0.35 raised per 9. This is 0.65 raised per 1. And then you have 10C10. This is 0.35 raised per 10. And that raised per 0. I'm not writing that. So if you simplify this, let me copy down the answer from here. That will be 0.995. Okay, this should be equal to 0.995, correct to three significant figures. Okay, is that the answer? I quoted it, I mean, first part's answer. Yeah, it is right. Yeah, this is going to be at most 7. Okay, so yeah, yes, 0.995. Okay, So we go to the second part then. Okay, it says the probability that Janice buys at least one item online in a period of n weeks, okay, another binomial, okay, it is greater than 0.99. So the probability x is at least 1. So this is greater than 0.99. Okay? So guys, this is going to be, we have this time your binomial distribution is n, and that is your 0.35. So this will be 1 minus probability x equal to 0 greater than 0.99. This is 1 minus nc0 0.35 raised to power 0 and 0.65 raised to power n is greater than 0.99. NC0 is 1, 0.35 raised per 0 is 1. So you have 1 minus 0.65 raised per n is greater than 0.99. So this minus 0.65 raised per n is greater than minus 0.01. When you cancel the minus with the minus, the sign of inequality has to be reversed, okay? And then you apply the natural log here. So this would be n ln 0.65 less than ln 0.01. You divide both the sides by ln 0.65, and once again the sign of inequality will change because both of them are negative. Okay, so when you divide them, let's see what we get. Ln 0.01 divided by ln 0.65. This is 10.69. And we have to find the smallest possible value. So n is going to be 11. That is the answer to this question. Okay, bacho. And I move to the last question for the day. Okay. Another question where you see we are clearly given that there is a normal distribution. Look at this. It is known that 20% of male giant pandas in a certain area weigh more than 121 kg. Okay, so that means probability that X is more than 121, that is going to be zero point 0.2. And then uh, 71.9% weigh more than 102. So probability X is more than 102 is going to be 0.719, where I had to mention that in the beginning, but I'm just going to justify this. Where X is normally distributed, it says find the mean and the standard deviation. So let's keep easier variables here rather than using, you see this mu and variance notations are very annoying. So I'll be using here x comma y square. Okay, so let's start doing solving this question here. So the first one would become probability that z is greater than 121 minus x over y, that is equal to zero point 0.2. Okay, let's simplify this. You see that there is a greater than sign and this probability is less than zero point 0.2. So this means this, all of this expression over here has to be negative 1. Okay, so this should be then, you will be, oh, I think it's fine. Oh, I'm sorry. This is fine. If it was more than zero point 0.5, then it would be a problem for us. So there is no problem with this. This is 1 minus phi of 121 minus x over y. That is zero point 0.2. So you have phi of 121 minus x over y. That is equal to zero point 0.8, and this 121 minus x over y is going to be phi inverse of zero point 0.8. Let's find that quickly. Where is that phi inverse of zero point 0.8? Phi inverse of zero point 0.8. Okay, zero point 0.8. It is here. This one, and then this 5. Okay, so it's 0.8, 1, 2, 3, 4. 0.842. 0.842. Okay, 0.842. So this is 0.842. So guys, your one of the equations is going to be 121 minus x. That is going to be 0.842y. That is your first equation. Okay, and then from this one, okay, you will start by standardizing. This is z is going to be more than 102 minus x over y. That is going to be 0.719. Now this is a problem here. We have a greater than sign and this one is more than zero point 0.5. Okay, just to make you realize, visualize this. If it is like this, it is going to be like this, and you see it is more than zero point 0.5. So this should be somewhere because all this area is going to be 0.719. So this is like, referring to a negative value here. So we have to make it negative, otherwise we will be stuck. Okay, so this is going to be probability z is greater than, I'll take a minus common from here so that this looks to be minus here. Okay, so this is 0.719. We have a greater than sign, we have a minus here. Remember, when you have probability z is greater than minus a, that is simply phi of a. Okay, so now this is going to be phi of this x minus 102 over y. That is 0.719. So x minus 102 over y, that is going to be phi inverse of 0.719. Let's see what is phi inverse of 0.719. 0.719. Okay, 0.719. Where are you? Hello. We have this exactly here, right? So it's 0.5, 1, 2, 3, 4, 5, 6, 7, 8. 0.58, okay? This is 0.58. So that is going to be equal to 0.58, okay? So you have your second equation, x minus 102 is going to be equal to 0.58y. You solve this, let me copy down the answer from here. Your mean should be, let's see what should be the mean here. Yeah, mean should be 110, okay? Your mean will be 110 and your variance, I mean, the standard deviation would be 13.4. So these are the answers that you guys will be getting, inshallah. Okay?